Okay, I will continue to solve problems about exact differential equations. Sorry, I need to make the videos short because otherwise it is very hard to upload it on the internet. So if it is too long, then it is hard to upload. So that's why I'm doing in parts. Okay, let's continue to solve exact differential equations. Okay, again, show that the following differential equation is exact, and then solve the differential equation. Okay, the idea is always the same, just the function m and n changes. So, but the idea is always the same. Or maybe I will write. Dy is equal to 0. Okay, I choose this example because I want you to be careful about something. Okay, this is our and for n, so we shouldn't forget this minus sign here. So you should consider it with this minus sign. Okay, because the equation was m dx plus n dy is equal to 0. So you should take minus with a minus sign. Okay, so in this case we have m is equal to y e to the power xy plus 3x squared, and n is equal to minus cosine y plus, so I will multiply with minus, it is plus e to the power xy, and we need to check that the derivative of m, which is the coefficient of dx with respect to y, so the derivative of m with respect to y, we have a very nice derivative here. What is the derivative of y times e to the power xy? So here is the product rule. 1 times the derivative of y is 1 xy plus y times the derivative of e to the power xy. So if you recall that the derivative of ax is a times e to the power ax. So here we are taking with respect to y. So a here x, right? So x times e to the power xy. And is it equal to derivative of n with respect to, which is the coefficient dy with respect to x. So here again we take, so this is minus cosine y, derivative is 0. Again 3x squared derivative, sorry I forgot to say, this derivative with respect to y is 0 here also. So here minus cosine y, we take derivative with respect to x, it is 0 plus, we have the product rule here, the derivative of x is equal to 1 e to the power xy plus, we are taking with respect to x, so y is a constant, y times e to the power xy. Oops. Okay, I will write. I will do it again. So we have the product rule. We want to take the derivative with respect to x. Product rule. Derivative of x is 1 times e to the power xy plus x times the derivative of e to the power xy. So y is a constant. It is y times e to the power xy. Great. So since we have the equality, since del m over del y is equal to del n over del x, the equation is, by theorem, the equation is exact. Great. So what does this mean? Then by definition, there exists a function f such that m dx plus n dy is equal to del f over del x dx plus del f over del y dy is equal to 0. And here we can see that these coefficients must be equal. So the del f over del x must be equal to m. And in this case, m is equal to y e to the power xy plus 3x squared. And del f over del y is equal to n. And in this case, it is cosine y plus x e to the power xy. X e to the power xy. Okay, to find f, so we know that f is equal to c is the general solution. So to find f, we choose one of these and integrate. So we will use these two equations, use these two to find f, two equations to find f. We choose one and integrate. Choose one and integrate. Great. Okay, I choose this one. Okay, we choose this one and we will just integrate with respect to x. So f of xy is equal to, so we think y as a constant here. So we are taking with respect to x. So recall that e to the power ax dx is equal to, the integral is equal to ax over a plus c. But in this case, we don't write c. And y is constant here. It's like a number 5. So you think y as a constant. You can think it like it is 5 e to the power 5x. So then what is the integral? Y e to the power xy over y plus the derivative, the integral 3x squared is equal to 3x cube over y plus the constant, but since we say we take the partial derivative with respect to x, constants are, so we should write c, but the constants are a function of y, right? Because y is also a constant, h of y. And to find h of y, we said we will use these two to find f. So to find h of y, we will use this equation. Use to find h of y. So del f over del y is equal to n. To find h of y, use del f over del y is equal to n. What was n? Sorry about that. Minus cosine y x e to the power xy. Minus cosine y x e to the power xy. Great. Okay, we will take this and take its derivative with respect to y. Okay, this y cancels. So it is x e to the power xy plus 3 cancels, so it is 0 plus h prime of y, and it is given as cosine, which is, we know it is n. So we know del f over del y is equal to n. Then here, if we cancel these terms, then we are left with h prime y is equal to minus cosine y. And we can take the integral to find h of y. So h of y is equal to minus sine y. So either you write plus c or take c 0, because we are at the end. We will write it as like this. F of xy is equal to e to the power xy plus x cubed minus sine y is equal to c, is the general solution of the given exact differential equation. Great. Okay, I think you got the idea. One more example. Okay, let's do one more example. 2x cubed minus xy squared minus 2y plus 3 dx minus, again here we need to be careful, x squared y plus 2x dy is equal to 0. So show it is exact and then solve. Okay, in the exam also I will ask like this, show that it is exact, and then just I want you to solve it. So okay, here m is this part, and don't forget and minus sign here. So this is our n. M is equal to 2x cubed minus xy squared minus 2y plus 3. So the derivative of m with respect to y is, so 0 minus 2xy minus 2 plus 0. What about the derivative of n? With respect to x, derivative of n with respect to x is minus 2xy, and it is minus 2x, so it is minus 2. So since del m over del y, del n over del x, by theorem the equation is exact. Great. Then we know that then by definition, so we know that there exists a function f such that m dx plus and dy is equal to del f over del x dx plus del f over del y dy is equal to, so df is equal to 0. And from here, df is equal to 0, we just integrate. So f is equal to c is the general solution. So to find the solution, we need to find the function f. And how we can find it? So this means that the coefficient of dx must be equal, so del f over del x must be m, and del f over del y must be equal to n. And in this case, m is equal to this function and n is equal to this function. Okay, I will write it looking at my notes. What is m? 2x minus y squared minus 2y plus 3, and what is n? Minus x squared y plus 2x. And to find f, we will use this too. We choose 1. So to find f, choose 1 and integrate. So I will choose this first one. Or should I choose? Okay, I will choose this time. Okay, I will choose the second one. Okay, let's do something different. So choose del f over del y, which is equal to, but I will multiply with minus 2x. And then I will integrate. So this time, but be careful, we are integrating with respect to y. Then f of x y is equal to, we are integrating with respect to y, so x is a constant, y square over 2 minus 2x y plus, and constants are x function of x. Let's say it is a function depends on x, g of x. So to find g of x, we will use this second one. We will use del f over del x is equal to m. Okay, now let's take the derivative of f with respect to x. So we will have del f over del x is equal to minus 2x times y squared over 2, so that 2's will cancel, minus the derivative of minus 2 xy is 2y plus g prime of x, and we know that this is equal to m, so we will have y squared minus 2y plus g prime of x is equal to m. What is m? So we can write it from here. It is 2x cubed minus xy squared minus 2y plus 3. So let's see what we have. We will cancel these terms and we will get g prime of x is 2x cubed plus 3. And by just integrating, we can find g of x. It is 2x to the power 4 over 4 plus 3x plus, let's write c1. So we will cancel these ones. Then what is f of x? F of x is equal to minus 2x squared y squared over 2 minus 2xy plus g of x, and we find g of x 3x plus c1. Let's say this is equal to c2 is our solution, and we can write this as c2 minus c1 is equal to c. So this is our solution, minus x squared y squared over 2 minus 2xy plus x to the 4 over 2 plus 3x equal to c is the solution of the given exact differential equation. Great, so here are some exercises for you. We will continue with the integrating factors.